going to keep moving into the next presentation. We actually have Heshan Samarawickrama, who is the manager from VBIS, coming in to have a chat with us in a second. And we asked him as well about, what he's been enjoying about COVID. And he said, look, it's just so much easier to get in front of people. And I think there was a comment that came up earlier on today. I remember what it used to be like trying to get a meeting with some of my clients, and you'd be booking in your calendar months out. And a lot of that time was just taken up with travel to and from, or, just that kind of the messiness of how life used to be. But now we can find little half-hour, 1 hour windows in our calendar all the time, and we're actually getting in front of people much, much faster. The other thing that Heshan said, which I thought was super interesting, is he loves working at home so that his kids get to see what he does. And I think that's a beautiful idea that, so often our work and our home lives are so divorced. It's not just that we can't take our home life to work with us, but it's actually that our home doesn't get to see the work we do. I think that's a beautiful sentiment to share. Anyway, without further ado, please welcome Heshan to the screen.
Thank you for that intro. And firstly, thank you to AMC and VBIS for the opportunity to give an update on VBIS and talk to you today about structuring your asset information to achieve built outcomes. So I'll get into it. So let's just start with giving you some context of why the development took place. And it really focuses on the role of information in asset management. And it tries to tackle maximizing the benefit of some of the industry trends we've seen over the last few years in this space, and also tackling some of the long-standing challenges. But I'll try and go through a couple of these trends and common challenges that we've faced. So the first technology trend there's been a lot of innovation in the construction digital engineering phase of the building environment, as you saw just in the 2 days alone here. And that means there's a lot of detailed information and useful information coming in from construction into operations. And these are things like BIM models, digital documents, and information databases. And then on the operations side, there's been a lot of development in technology through the various PropTech cycles. That's meant that we're now monitoring and gathering a lot more information than we used to on real-time performance of assets through various sensing and IoT devices. And on top of this, it's actually getting a lot cheaper to store information. So as a result of all of this, we are kicking off with a lot of information coming in from construction to operation, and then we are gathering a lot more information across the life cycle of that operations phase as well. And what this means is we need to have a quick way to actually access all of this information and get to the right information that we need to get to actually accomplish asset management activities. And on the second technology trend, it's the bolt-on tech, as I call it. And these are things like analytics. It's been an industry buzzword for a long time, but it's really getting very practical to deploy and to get good outcomes these days. But the practical outcomes are very much dependent on the quality and the consistency of the information that is fed into it. Otherwise, it tends to be a bit rubbish in, rubbish out. And yes, that is a technical term. On to the challenges. The first one we've highlighted is actually, you can see on the screen there, and that's the fact that in the operations phase of the built environment, there's many stakeholders, and these are people like the asset owner, the asset operator, and all the disciplines of maintenance providers. So there needs to be a consistent structure prescribed, not just in how you record your assets, but also then all the subsequent information of those assets so that you can make meaningful insights and outcomes. And if that isn't prescribed, then it falls down to the respective stakeholders to develop their own methods. And as a result, it doesn't really roll up that well to again get that whole portfolio view, wide view, if there isn't a consistent way to prescribe at the start. So there are already a lot of good classification systems out there. But in the research that we did at the start of this development, what we found was that a lot of it really focuses on the construction and the quantity surveyor kind of phase of the built environment. So as a result, it doesn't always have the granularity needed for tasks like lifecycle planning, maintenance planning, and performance benchmarking, which are key for that operations phase. And the second challenge is really around the disparateness of stored asset information and the ability to actually quickly access the information that we need. There's actually one of the previous presentations actually touched on that and went into a lot of detail around the benefits of integrating siloed information, which I thought was really interesting. But let me just run through a quick example of what I mean by that in the next couple of slides. So this is a typical life curve of an asset. So you can see that at the start, it's brand new, its resistance to failure is quite high, but as it progresses through its life, that starts to change. The maintenance requirements start to change. And what I'll draw your attention to is that red dot towards the end, which is the functional failure point of the asset. Now, the aim of the asset manager and the operations team is to move that red dot to the far right as possible. So you're essentially trying to sweat the asset for the longest period of time without impacting the stability of operations. And to do that, you really need to have a good handle of making sure that you're doing the adequate amount of maintenance and making sure the asset is obviously okay to operate for that longer period. And the other aspect is you still need to have a good handle of where that red dot sits, because you need to have capital planning and operational planning in place to make sure that you're planning for the replacement when at such time that red dot does appear, you are planning for that replacement. And how this links back to asset information is the information needed to make an accurate judgment call on where that red dot sits actually already exists, but they happen to be in different applications. So a couple of examples here. You can see how the frequency of failures, which tends to increase as you get towards that red dot, is actually recorded in a number of systems already. And example there on the top could be a help desk system or a maintenance management system that's recording work orders logged, which, as you can see, is capturing that increasing rate of failures. And the other graph towards the middle there is either a financial system or an asset management system that's recording the increase in reactive spend that the asset owner and the operator are obviously spending to get those reactive, the faults and things like that fixed. And again, what this is highlighting is that disparateness of information. And if you had a consistent asset reference system that's able to tag that information and then bring it all together, it would then allow that full insight to be as accurate as possible in your operational planning activities. So with all of that in mind, hopefully that gives you a bit of context of why we went down that development path. And we wanted to obviously have this VBIS standard available to the market. And so that's the why. Here's the how. So what this was funded by the Victorian government over a 2-year period. And what we did was we formed a project consortium. So AG Coombs is the lead partner. I've been around for 75 years and across many things like project service, FM and advisory. So have intimate knowledge of the practical implications of needing asset management. Bella Jack came on board as a government liaison and the overall project manager for the development. And Wise Working came on board as the technology partner to help test the standard in commercial applications. And when the grant period finishes and the development completes, the classification system and the tagging will fall over to the custodianship of BIM-MEP-Oz so that the long-term viability of the standard is intact and that's stable. Now, in parallel with this, a few other things happened. So the Victoria government obviously recognized that they were going through, I think, about $80 billion of development in the next 12 to 24 months alone. And they wanted to have some sort of standardized approach in how they digitally construct and also digitally asset manage the infrastructure that are coming up. So they released the Victoria Digital Asset Strategy, and VBIS is endorsed and included in there for asset classification and linking asset information together. So that was in March. And then in July, the Queensland government also followed and released the Data and Information Guideline. And again, VBIS is endorsed and included in there for asset classification and linking data together. And then more recently, VBIS signed a collaboration partnership with the BRIC initiative in the US. BRIC is a collaboration between ASHRAE, Project Haystack, and a number of universities in the US. And they have a full asset relationship structure. So we saw a good alignment there with what they've done and how VBIS can add to that model to essentially superpower that to then start modeling asset management activities. And BRIC has most recently been picked up by Google for their digital buildings initiative. So it has that global presence, and it's great to see their endorsement in getting the VBIS classifications mapped to their modeling. And obviously we have a close working relationship with Uniclass and Omniclass, which I'll talk about a bit later in the presentation. So that's the how. And now I just want to go through the objectives of what we wanted to cover with the development, just so that you're clear on exactly what the outcomes were. So firstly, it's an open standard for the classification system and the tagging, and it's not software. So we had to start putting it in bold and underline because people initially started thinking it was a software platform. And that's done intentionally because this has to work within current commercial applications and be system agnostic so that we can provide that consistency of asset information across the board to then help support asset management activities. And that also then helps with ease of information handover through key workflows. So one of them is obviously the procurement process, which again, I'll talk about a bit later. And the other key one is construction to operations. So that's really by having the end in mind and having the granularity of the asset definitions needed for that longer asset operations phase, so that that can be embedded in the construction phase, not by adding any more work in the construction phase, but still actually making it easier in terms of increasing the efficiency of the handover to operations. And the other aspect is BIM and FM, been around as a concept for a long time. We'd like to see more uptake in that space. And what VBIS facilitates in that connectivity is better access to information in BIM models for people in the operations phase from the applications they're already comfortable using, like the asset management system or maintenance management system, to then actually be able to interrogate BIM models and get the great information that is coming through from construction to then make better use of it in their daily asset management activities. And all in all, it's really about making activities more efficient to then help reduce cost in that ongoing operations period and the activities by having better access to information that they already have. So with those objectives in mind, what is VBIS? So VBIS is two parts. First one is the classification structure and the VBIS tag. And the second part is what we call the search syntax, which then helps the user go and actually find that information that sits in different places. So going into a bit more detail, firstly on that first part of the VBIS standard, which is the classification structure and the VBIS tagging, what we've developed is a 4-level structure. So the first level is the discipline that the asset sits in, and level 2 to 4 then goes into the detail of describing each asset type down to the level of granularity needed in those operational activities. Like I mentioned before, lifecycle planning, operational maintenance planning, and performance benchmarking, and even contract management. And so you can see a couple of examples there on the screen of how the 4-level structure gets laid out. And what then happens is that rolls up to what we call the VBIS tag that you can see in the middle of the screen. So the VBIS tag is alphabetic. It's representative of the 4-level structure, as you can see. We put in industry common acronyms to make it as human readable as possible, on top of it being alphabetic. So as an example, the pan, tilt, zoom camera in a security system, the security guys know that as a PTZ camera. So we made sure to include that PTZ acronym at the right level in the VBIS tag. So with it being human readable, what we're hopeful is over a period of time, people can actually start to understand exactly what that asset is just by looking at the VBIS tag. And being human readable also helps with the wildcard searching capability. So I'll point you to the bottom half of the screen now to go through an example there of 2 pumps. So they're actually the same type of pump. So they're both centrifugal axial split pumps, but used in 2 different systems. So the chilled water pump obviously sits in a mechanical system, and in the VBIS tag, that's highlighted by the ME at the start of the tag. And a water pump that sits in a hydraulic system, and that's highlighted by the HY at the start of the tag. But what you can see is level 2 to 4 is the same, because they're still the same type of pumps used in different systems. So that consistency we've built in across the board, where there's similar assets being used in different disciplines. And what that helps is then help the user cut the data in different ways to draw the insights that they want. So there's a few other examples at the bottom of the screen of how you can search for maybe all pumps in your portfolio or all centrifugal pumps, irrespective of discipline or by discipline, and etc. And cut the data in different ways. Now I just want to show you a screenshot of the classification table, and just to give you a sense of how that looks. So here's a screenshot of the chiller section in the mechanical discipline. So level 1 is obviously mechanical, and you can see level 2 to 4 defined on the left of the table, and that lines up with the BIM-MEPOS product type classifications as well. And so you can see all the different types of chillers in this case detailed out, and then how that rolls into the VBIS tag that you can see in the middle of the screen. So they're quite consistent. They're obviously all alphabetic. And what I'll draw your attention to is that they can be in different levels. So there's level 2, level 3, and level 4, as you can see, depending on the level of detail that you want to tag to. And that's important when you consider the life cycle of these assets. So you might be at a concept design stage where you know there's a chiller going in, but you haven't really picked what type of chiller it's going to be. So what this allows you to do is tag it at the level of information that's available, but then keep building on it through the concept, then detailed design as built. And then when it comes time to hand over to operations, you've gradually built that out so that it's at the granularity needed for that operations people to make that handover process a bit more seamless and not have that to and fro at the end in the handover process. I mentioned Uniclass and Omniclass at the start, so we've also mapped the product codes at the right levels in VBIS as well. And as you can see, there's a few examples there for the chillers. And what this lets you do is then figure out where the Uniclass and Omniclass codes sit in the right level of granularity in VBIS, and then the extra level of detail that's available after that. So VBIS is very much about working in with other classification systems that may have been adopted by asset owners. And you can see that by the mapping, you can then build on that and get the extra level of detail, whether it's any of these ones or even a bespoke one that someone's decided to run with. So hopefully that gives you a bit of an overview of the classification and the tagging. I just want to go through a quick scenario of how VBIS, the tags would then get applied into a building. So this is a building that's a couple of decades old, so it's gone through a few upgrades over the years. You can see the top 2 pumps there they've actually adhered to the BIM-MEPOS naming convention, but sadly for the rest of it, they've decided they haven't done that. So the naming convention's a bit all over the place. And now they're going through a new upgrade and adding a few assets in. So in this case, you allocate the VBIS tags alongside the naming convention, so just an extra field in this case. And what that then gives you with the wildcard searching capability is a clear digital structure for allocating your new assets, so that you've got the clear digital structure and you can add and remove assets clearly, and then also search for assets clearly without omitting any in your day-to-day activities. Now, the other aspect is having that discipline at the start, and the fact that the discipline aligns with the different trade disciplines. That really helps with digital procurement and digital contract management activities. So as you can see here, you can do a search for all of your mechanical assets, all of your security assets in this example, so that you can get a clear asset register that makes up the scope of work for the different contracts that needs to be either tendered or managed in the built environment. And obviously having the full 4 levels or the full VBIS tags tells you exactly what type of assets they are, which then provides that consistency to then support asset management activities as listed on the screen there, to ultimately help be more efficient in reducing costs and most importantly, managing risk as well. So I mentioned disciplines a few times in the presentation so far. I just wanted to cover what disciplines we have with VBIS. So that's a quick snapshot of what we've done to date. And that's not to say these are the only disciplines that we'll cover through VBIS. We prioritize buildings and the assets within the built environment to begin with. But since then, we've had interest from the transport and the water sector, for example, saying, look, we like the 4-level structure, but notice that our disciplines aren't listed on here. So we're more than happy to work with them and then get those built out. And that's the discussion we're having at the moment. So the 4-level structure we've developed can easily be expanded to then add new disciplines by still keeping that integrity of how we've done the tagging in place. So that's been no issues at all. So that really covers the first part of VBIS, and hopefully that gives you a good sense of the classification, the tagging, and how it can get applied. So now I'm going to kick off on the second part of VBIS. So the premise here, as you can see on the screen, is information related to different asset types sits in different applications, and that's by the nature of the type of information or the format of information. So a few examples you can see on the screen there. There's BIM models, there's documents, there's database records and the like, and ultimately they sit in best of breed applications that are different. And at this point, with the VBIS tagging, you know what the information is because you've meta tagged the data, but now you need to be able to quickly go and find that information that sits in these different applications. And that is what is catered for by the search syntax. So here's how the search syntax works, and VBIS is all about keeping things as simple as possible and stable as possible. So we adopted a URL format to pass search requests from one application to the other. And what we've done in the VBIS standard is to define the parameters that sit within that search request. So we've got about 40 odd parameters in the VBIS specification that we've defined that covers geographies, organizational hierarchies, GPS coordinates, unit asset IDs, barcodes, QR codes, GIS codes, and all sorts of stuff, and obviously including the VBIS tag as well. And how that works is, as you can see on the screen, one example there, you might be in a BIM model or a virtual tour. You want to get more, you want to see the documents related to this chiller. So you trigger that request, which might be clicking on a button, which then triggers that URL request, which you can see the example of on the screen. What that's basically saying is, show me all the drawings related to this chiller that got installed in the project called project name. And you can see that by the parameters in there, that is what it's asking for. That then gets passed into the document management system. It does a search and displays the documents for the user. So with this, we're avoiding hard-coded links, and it also gives you the flexibility to swap applications in the future, where you just need to basically swap out that domain name at the start of the search syntax, where everything else remains the same. So the integration aspect becomes a lot simpler. And if people are updating information in the other applications, that doesn't matter either, because it's always a search request. So any updates will still come through. So there's no links breaking or anything like that. And there can be high confidence that it's always the latest and correct information that's been found. But it's not just about documents. You can obviously do the same thing for maintenance records into a maintenance management system, performance monitoring into analytics platform, construction records coming in through the BIM model, and also searching for parts. So what we've done there is we're in discussion with a number of product vendors. So Reese Group have come on board most recently, where they've started tagging their HVAC products. And I think they're up to about 26,000 assets last time they gave me an update. And you can actually search for products by the VBIS tag on their website. So what we're hoping there is how we can simplify the procurement process by passing the VBIS tag, and you can get pricing by different manufacturers or cost comparisons and the like quite easily by being exact in the equipment type definition using the VBIS tag. So the two parts of VBIS then come together with commercial applications to form the VBIS-enabled application ecosystem. So in this ecosystem, you know what all the information is because they're all meta tagged, and you know how to go and find them because the search syntax offers that connectivity or linking functionality. Now I'll play a video that gives you a bit of it gives you one example of three applications working together just to give you a sense of how this ecosystem actually gets delivered in a practical example.
This is an example of a VBIS-enabled ecosystem consisting of three different applications. First one is a 3D model, then second one is a maintenance management system, and the third one is a document management system. Each application contains asset information, but are all very different, and VBIS enables the user to link it all together for easy access. We start in the maintenance management system. I'm just doing a filter for mechanical pumps using the VBIS tag. And now I want to look for documents related to a specific pump. So I click on the document search link, which takes me to the document management system and displays the results. I can now look through the documents that have come up and use them for the activities that I had planned. Now back in the maintenance system, I want to see where the asset sits in the physical space. This is then triggered through the 3D model link that takes me to the 3D model, and I can look around, do my measurements, and plan my activities there. I can also access extra information from here, such as the asset record, which takes me back to the maintenance system, where I can access fault histories and condition ratings, or I might want to look at similar assets, where I can get an idea of how many assets of this type sits in the portfolio for comparisons or profiling. Or I might want to look at extra documents, such as the specifications. So again, click on the link, which takes me to the document management system. And again, like before, I can look through the documents and get the information that I need. And while I'm in the document management system, I can also look for assets related to the different documents, and then get a sense of where the asset sits in the physical space, which is then back in the 3D model. So hopefully this gives you an example or an overview of how the VBIS-enabled ecosystem gives you access to different asset information.
Right, so with that video, hopefully that gave you a bit of an example how the ecosystem works out. And now I just want to finish up by covering the different content and support aspects that we can offer through VBIS. So the first one is obviously the classification tables and the VBIS tags. So that's aligned with the BIM-MIP-OZ tables, and that's freely available from the VBIS website. You can go in and download that now. The second aspect we've got is the VBIS-enabled partner program. So that's really for software vendors to get their products VBIS-enabled. So that means getting the VBIS tags incorporated to have the classification structure in place, and also to understand the search syntax language, the common language between different applications, so that they can be essentially a Lego block in the end user's Lego model. There's a number of vendors that have already come on board, and there's also a number of software applications that actually can just work with VBIS out of the box without needing any configuration. So there's a few examples there listed of both of those types of examples of applications. And the last aspect there is obviously the support capability. So we are able to provide help with planning out the whole information requirements, the asset information architecture component of this, and also help with either adopting the standard or building up roadmaps on how you want to get there and things like that. So we've deployed a number of ecosystems to date, working across a few different organizations in different places, and we're happy to continue to do that as and when needed. So reach out. So thank you very much for your time, and apologies for that narration on the video, but hopefully the visuals gave you a bit of a sense of how the ecosystem works together. And I'll leave you with this image here where it's showing practical asset information of different types connecting together in an ecosystem arrangement. So it could be people in the operations phase where they are walking through the building, bringing up the virtual tour, then accessing different parts of information, whether you're a FM or a technician, to get to the right information. Or you might be in the capital works or project side of the business where you're planning an upgrade and you want to get the current information so that your planning can be as accurate as possible, and then feed that into the project cycle. So in all, it's really about right information to the right people at the right time. Thank you.
Thank you so much, Heshan. I think, again, it kind of just highlights the value of visualization when it comes to kind of communicating and engaging with other people, within organizations and within projects.